let's see, f of x is this thing, and then the derivatives are given. Otherwise, you're going to die taking the derivative and computing and everything on the exam, right? A lot of times those derivatives are given, and that's why there's gateway. So you know your derivatives in one place, and then you know how to use them one other place. So all of these are given. And so the next thing is it's asking, what is the domain of f? A is the domain of f is. So I'm looking at this. How can this, what x causes trouble for this function?
0.
0. So if I exclude that 0, I should be okay, right? So that's what happens. Instead of negative infinity to infinity, you will have negative infinity and 0 and 0 to infinity. So part B, it's asking what are the horizontal and vertical asymptote, vertical or horizontal asymptote of this function, right? So we're looking for HA and VA. So how do we find them? HA is related to the limit of limits as we expand, right? That's the HA. Horizontal asymptote is the limit as we go this way. And so that's how let's say we remember it. If I horizontal means my arms are like that, and I expand, my tip of my fingers are going to infinities. And so that's the HA is limit of the function as we go to one infinity or the other. And I think it turns out in this case, I can put both of them at the same place. Okay, so y equal to that limit, because the limit exists. What do you guys think the limit is going to be?
I imagine
There isn't one.
infinity over infinity.
Well, yeah.
So what kind of, now you have a lot of tools. You can do a ton of stuff. Can I do L'Hopital with infinity over infinity?
Yes.
Okay, so I did one L'Hopital. Is it still infinity over infinity?
Yep.
Okay, let's do one more L'Hopital. 3 simplify. Now 2x minus 1 over 2x. Can I do one more L'Hopital because it's still infinity minus infinity?
Totally.
Okay, so limit.
Excuse me.
Yes.
Aren't we supposed to be starting off with x squared in the denominator?
Was it x squared in the denominator I'm doing? Oh,
Yeah, it actually is. I didn't notice.
Yeah, me neither.
Thank you so much.
And is that just infinity? Just flat infinity?
Yes, it's flat infinity. There is no horizontal asymptote. Otherwise, it would be 1. But then this is a good point, though. You figured out if the two, see, this is x minus 1 to power 3 and x to power 3, right? The polynomials, the way that I wrote it, which was wrong, it wasn't a problem. I was having the polynomial on top and the bottom had the same degree, and both had the leading coefficient 1. And L'Hopital rule took me to y equal to 1, and the other one took me to y equal to 1. But I was not supposed to do that at all. Sorry about that. And so we're going back here and that. And so I'm finding this limit. And this one, the top is 2 power 3, the bottom is of power 2. Now that we know L'Hopital rule, this means that that one is growing faster than this one. And I can say that now if I want to. So this is infinity. So no one of those. But what about vertical asymptote? When is vertical asymptote? When x, when the denominator is
0.
0. So that's one of the places for quotient function, that's when we have a vertical asymptote. So x equal to 0 is the vertical asymptote. So that said, now what we're doing next is find what? Intervals of increasing, decreasing. And so when we're finding increasing, decreasing, it's all about f prime. F prime is 0 at 1, at -2, and 0. It is the denominator, right? 0 of the denominator, so the critical points are x equal to 1 and -2. But point of interest is x equal to 0. Why is it point of interest? Because it's not part of the domain. That's my other way of saying that even though it's not a critical number, I need it on that number line. That's all it means. It's just vocabulary that people, and it differs. It's not an important vocabulary basically. But I like to call them all points of interest. And critical points are points of interest, and these type of points also are points of interest that you want to put. That means that I want them on number line. So f prime, there is -2, 0, and 1. Now that I have that, let me write down f prime right next to this, because otherwise I forget. It's this times x plus 2 divided by x to the power 3. Now, if you look at the degree, what's that called? I'm having a moment again. What is the 0? The power of the 0 is called, can anybody remember that word for me?
Degree?
There's another one.
Multiplicity.
Multiplicity, thank you. So the multiplicity of 1, x minus 1, right? That one is 2. Multiplicity 2 means that the sign doesn't change. Multiplicity 1 for x equal to -2 means sign is going to change. Multiplicity 3 also means that the sign is going to change. As x is a big positive number, here it's a positive number, right? At 1, the sign doesn't change. At 0, the sign changes. At -2, the sign changes again. So that's the trick. I go with one way that is easy, and then just change the sign all the way through. You guys are following? Okay. So now f is increasing here, decreasing, increasing, increasing. So f is increasing at -infinity. My handwriting is going south very quickly, partially because I like it a little bigger, I think. Not that big, not that big. There we go. Okay, so f is increasing from -infinity and -2, and then 0 and 1. Again, at 1, f prime is 0, therefore you have to exclude that one, and then add 1 and infinity. So that said, decreasing, f is decreasing, decreasing only between -2 and 0. Okay, do you
Can I
guys
ask something real fast?
Sure.
Sorry.
Go ahead.
How did you find that, like, how did you know that there was no horizontal asymptotes? Like, when you set, like, the limit to infinity, like,
Mhm.
how did you know,
So,
or, like, plug in that infinity
the-
to know?
this is the fun part. Now, in chapter 2, see, this polynomial is of degree 3. Do you see up there? Elizabeth?
Sorry, what did you say?
The polynomial up there is of degree 3, right?
Mm-hmm.
And polynomial on the bottom is of degree 2.
Oh, so like if it's equal or if like the one on top is bigger or equal to the bottom, then there's no horizontal asymptote.
And so if the degrees are equal, there is a horizontal asymptote.
Oh,
If the
okay.
degree of top is
What would
less
that
than-
graph look like?
what do you mean? And if the, like, let's say if the polynomial on top is, let's say, x over x squared plus 1, then this is going to be 0. So y equal to 0 is the horizontal asymptote. If the
And
degree of
that's because like so how did you know that like it was going to be 0?
okay, so because the bottom, again, we have one way in chapter 2, now we have another way using L'Hopital. I know that the bottom grows faster. Do you remember I wrote f of x is much bigger than g of x? So x squared plus 1 is much bigger than x. And because
Mm-hmm.
it just multiplies. And so that makes it, this makes this very heavy. And as
Do
it
you
goes,
like factor out like just algebraically, like do you
do you want to do
factor out
algebra?
like the x squared? Sorry,
Mhm.
I'm asking so many questions. This is something that like I've always kind of struggled with. Like I
That's
get
okay.
the vertical asymptotes, but the horizontal.
That's okay. This is, so over here, if I have that, yes, you can factor out. Let's say I'm going to factor out x squared, and what I end up with is
Oh, so it's like 0 over 1.
it would be 1 over x over 1 plus
Okay.
x squared. Like that. Right?
Okay, that
So-
makes sense. Mm-hmm.
So that's that one, and then through actually L'Hopital rule. I think one of those videos that we have explains why L'Hopital rule works, and and that helps a little bit sometimes to trust the L'Hopital rule. And so L'Hopital rule does work, and so we know that a polynomial of degree lower through multiple application of L'Hopital rule will become 0 before the polynomial of a degree higher. And that's why degree of the polynomial, one grows faster than the other, basically. So that's the other thing that we can do. So I'm gonna go to concave up and down, but do we want to get rid of part E already before going to D? Shall we do that? Yeah. I think it's time to do that. It seems like
Yeah, 0.
I have a question real quickly that kind of does go along with part E. So for the test, can we put like x equals -2, or do we have to like put the actual point?
So if it's asking the critical points, just put in the x value and the y value.
Okay.
To be safe, I think it's the best. The local local max point or local min point or extremum points. That's both of them together, I think the best. So here 0 is not part of the domain, right? So no, not to worry about that. Here I get a local max, and here I get nothing, right? This one is neither. So I do have a local max, but on the other one, I don't have anything. So now let's move on to, we come back to this, but let's move on to D. D says on what interval f is concave up and down. And if double prime has 0 at 1 and other interest point is 0, And then if you look at the 0, 0 is of even multiplicity. No, Elizabeth, don't memorize that one. I'll give it to you if you need to. And so that's the multiplicity 0. Multiplicity of 0 is even, therefore the sign doesn't change, but 1 is odd. And if I'm going toward the positive infinity, this is positive infinity, it changes, but it doesn't change here. So this was F double prime. Now, F is going to be frowny face, smiley face. And so the concavity of F is concave up at 1 and infinity. F is concave down at negative infinity and 0 and 0 and 1. All good?
So it's concave up just if it's positive.
Yes, concave up is positive. Yes, so positive is the smiley face, and basically there is a valley, and then the hill is in the frowny face, and when the F double prime is negative, basically. Okay, so that said, let's put them all together. Let's answer E. E is telling me that F has a, was it local min? Local min at -2. So plug it in to find the -2. F of -2 is equal to -2 minus 1 to power 3 over -2 to power 2. And that's -3 to power 3 is -27 divided by 4, right? So -2 and -27 divided by 4 is local min. Local min.
E should be max.
Was
Yeah,
it
it should be a
max?
local max. There
Oh.
is no local min.
Okay, I cannot read my handwriting apparently. Yes, that's a max, not a min. Okay, so this is a local max. Ah, that was that's good. Then the next part is F. At what point F has a local min? No such thing. Nowhere. And then G, what is the inflection point of F? Let's see, inflection point of F is point that F prime changes, that F changes, it's a point in the domain that the F prime, that F changes concavity. I think I got it right. Is there a point that F changes concavity?
Well, wait, I got one question. We're saying that there's no local minimum, but it goes from negative to positive at 0.
Yeah, but 0 isn't in the domain.
Not in the domain.
Oh, non-domain. Okay, my bad. Thank you.
That's okay. So, but here, everybody sees that 1 is the inflection point. So x equal to 1 is the inflection point. Inflection point at x equal to 1, there is an inflection point. And you can plug it in, and inflection y value of the inflection point is just 0. And so it's 1 and 0. So we found these points, and then at the end it's saying that, oh, graph this thing. And so when I'm graphing, back in the day that we could give you a grid to graph, good old days. Well, we'll eventually come back. So now we have the 1 and 0. And then the other one was -2 and -27/4, right? So that's the, what was the local max? -2 and -27/4, which is about -6. So -2, -2, and -6, and this is supposed to be a maximum. And what else do I know? I know at x equal to 0, there is a vertical asymptote. And so that's the stuff that I know. Now I want to use the shape of the graph though. Let's go back and figure out the shape of the graph. So I'm going to make this a little small, no, a little smaller. There we go. Now, here is, see, -2 is happening. Let me write them over here. -2 is here, 0 is here, 1 is there, and over here, 1 and 0. And then concavity is like that. And then increasing, decreasing is like this. And so right about here, for these two, the shape is decreasing. I'm putting the concave down. One shape is like that. One shape is like this. That one is like that. This one is like this, right? Did I do all of them correctly?
Isn't it supposed to be positive after 1? So it's supposed to go. Never mind.
One.
Or me.
Oh,
Yeah,
yeah,
it's
you're right.
positive.
It should be positive. It should go the other way.
Yeah. Thank you. So, thank you. And so positive, and it goes like that then. So that was one point of concavity and point of inflection.
Yeah, it is.
Okay, good. So I can see that now. And so put all of these together. Remember, this piece, this piece, this piece, that piece, right? So let's put them all together because I can make it a little bit smaller. It won't look very good. So here, this is the point of inflection. After the inflection looks like that, so I put that piece like that. Before that looks like this, I put that. Oh, and I see the, see when it's too small, I can't draw very well. And then over here, I have going this way, and over there, I have going that way. So now let's make it a little bit bigger. Not too big, not too big. There we go. Now a little bigger. Okay, so basically what I saw was that before the inflection, it was going like, oh, over here looking like this, and then looking like that, and that's the local max, and that's the shape of the graph. And this side is asymptotic toward that way, but that one is going to infinity. Okay, do you guys see what I see?
I have a question on this one.
Yes.
On the test, are you going to be looking for the shape, or are you expecting us to also put points in there where we know where they are?
Okay, so there are two types of questions you can get, Ethan or Luke. One way is that I don't even give you any option to find a point. So then I'm just looking for shape. But sometimes there's options, so maybe a couple of points, like I did. Like find a y value for the extremum, or find a y value for the inflection point, and then rest is okay. Is that fair? Luke, did I answer your
Yeah.
question?
Yeah.
I have a quick question about C, if we can go back a little bit.
Okay. Okay, what's up?
So for the interval where f is increasing, I was confused on why. Can I see what you had written? Sorry.
Okay.
So where you broke it into the
Mhm.
infinity to -2, and then 0 to 1, and then 1 to infinity.
Mhm.
Why couldn't it be 0 to infinity?
Oh, because so the story was that y prime was 0 at 1, right? So we are increasing is only happening when the function is the derivative of function is positive, not 0.
I
So
see now.
at that point it was 0. That's why. So basically,
Okay.
t line is horizontal, so it doesn't count. That point is out. That's all.
I have a quick, like, unrelated question.
Yes, Kyle.
So is percentage error just equal to relative error times 100?
Yeah, yeah,
Okay.
basically. That's the same thing. I don't care even if you don't multiply by 100. It's just percentage error sort of makes more sense. People say, what relative error to what? But percentage error, you know that you're kind of finding relative to the measurement. I think percentage error is the word that people like better. That's why it's used, basically. Okay. So which question? I have 2 more left, or 3 more left. Do you want one more of these, or do you want to do those and then do one?
Actually, can I ask about question number 6, because I was just looking over the stuff that we wrote down. So we have f of 1 equals 3